Basic switching concepts. Now probably in the next couple of videos we'll be getting into some of the basic switching concepts, like what are the difference between hub and switch, what is broadcast domain, collision domain, and different types of basic switching like what is ARP. And then after that we'll be getting into some of the advanced switching concepts like VLANs and trunking. So let us start with some of the basic switching concepts. Now if you talk about if you just get back to the basics of what we have learned, we have seen something called a router. Router is a device which provides a WAN connection, which is generally connected, provide a connectivity between two or more different locations, and it will do the major job of a routing, which will allow one network to communicate with other network. So that's something what routing, and the routers are the dedicated devices which will do routing. But now whatever we have discussed in the previous sections, it's all about WAN, how it's going to be done. But now the question is, how about LAN? In the LAN, how exactly the process happens, what happens in the LAN, and what are the different protocols works in the LAN, and how the normal LAN networks are built. Something on that we'll be discussing in these sections here. Now there are two major devices which are used for providing the LAN connections. Initially we have something called hubs and the switches. Now both are exactly will do the same job. So they both are the devices, a centralized location where you can connect all the devices in the LAN. So it provides a centralized location, both hub and a switch, but hubs are something which are not used in today's production networks. Now one of the major reasons, there are many reasons for not using the hubs. That is something what we will be discussing now. But diagrammatically, when we say hub, we will see single arrow, and switches are represented with some multiple arrows like this. Let us try to understand what's the difference between hub and a switch. In that, the first major difference is switches are much more intelligent devices when compared with the hubs. They can identify the device based on the MAC address, and they maintain some information called MAC table. So they can identify the device based on the MAC. Let us see what is exactly this identifying the MAC table and how it's going to work. So let's take an example. I got a switch which is having some ports 1, 2, 3, 4, 5, 6, and it's connecting to some devices in the LAN. So I got 1, 2, 3, 4, 5, 6, all the devices. Now assume the IP addresses of these devices are 192.168.1.1, 1.2, 1.3, 1.4, 1.5, 1.6, all are 192.168 in the first two portions. And also assume that the MAC address of each and every device is AA, AB, AC, 2C, 2D, something like 3F something. Now normally the MAC address will be 48-bit address, so I'm just writing only two numbers here. Normally it will be a 12-digit number. Just to make it easy to understand, I'm using some sample MAC addresses. Now this is your IP address and the MAC addresses. Now let's take an example. I'm sending a request. I want my device to communicate between 1.1 and the destination address is 192.168.1.4. So maybe you are generating a ping message, you are sending a request from 1.1 and I want to communicate with 1.4. Now what generally we do? So if you are using a ping message, we generally type 192.168.1.4, the destination IP address. Now once you send the destination IP, probably you'll get some reply messages, right? If the connectivity is okay. So that's something how it's going to work. But the problem here is the switches. Now this is my switch. Now switches do not understand IP addresses. They only work based on the MAC. They only identify the MAC addresses. So which means even though you are sending a request based on the IP addresses, but still internally there is a protocol called ARP, Address Resolution Protocol, which is going to convert your IP address into equivalent MAC address. Now in my scenario, what is the MAC address of 1.1? So the MAC address is AA, and the MAC address of 2.4 is 2D. Now before it sends a ping request, the PC is going to send a broadcast request to everyone saying that the destination address is 1.4. What is the MAC address of 1.4? It sends an ARP request, and then 1.4 is going to reply with that ARP request saying that I am 1.4 and the MAC address of my device is 2D, and then the switch will identify, the PC will identify the source MAC and the destination MAC. So when the packet is sent to the switch, it is not going based on the IP addresses, it will be sent based on the MAC addresses. So it says that the source address is 1.1 and the destination source address is A.AA and the destination address is 2D. So in short, when we come back, we'll verify all these things. For verification of this, what I can do is I can take my switch here. You can see I got a network here and I got some computers connected in the LAN, more similar to your. I got some computers with their own IP addresses. Let me show you. This is 192.168.1.1, 1.2, 1.3, 1.4, and the IP address on the router is 1.100. I'll go to one of the PC command line. Let's go to the command line, and to verify this ARP table, we can use a command called ARP-A inside your command prompt. Right now you can see I don't have any entries. So what I'm going to do is I'm going to generate a ping message, a request to 192.168.1.4, and then you can see the reply is coming, but internally inside your PC it is going to resolve the MAC address of that particular device. Before it sends a reply, it's going to find the MAC address, and this is the MAC address of 1.4. Similar way, if you try to ping to 1.3, 1.2 and 1.100, that is the router, and you can see if I give ARP-A, you can see before it sends a ping request, it first resolves the MAC address, and these entries are dynamic. That's what it says, dynamic entries, and they will be removed after some time. Now the backend protocol is ARP, so we have nothing to do here, so we don't need to worry about this, because whenever a PC has to send any packet to destination, it resolves the MAC address, and that's what ARP protocol will do, IP to MAC resolution. Because the switches do not understand the IP address, they only understand the MACs. The next thing, now let's try to understand how the switches, how we can say that switches are more intelligent devices. Now the switches are more intelligent devices. Why? Because they are capable of identifying the device based on the MAC. Like it can identify on which port, what is the MAC address connected, based on a table called MAC table. A switch is going to maintain one table called MAC table or CAM table, and that particular CAM table or MAC table is having on which port number, what is the MAC address connected. And whenever you power on the switch for the first time, the default MAC table will be empty, and we can verify this with a command called show MAC address -table. This command will verify this in short once we discuss the process. Now when you are sending a packet, now here I am sending a request here. The request is coming from 1.1, and what is the source MAC address? It's coming from port number 1. So it will see that on port number 1 there is a device with a MAC address of AA. So there is no entry. If there is no entry for AA on port number 1, it will write down that entry, and it will see what is the destination MAC address. The destination MAC address is 2D. Right now in my table there is no entry for 2D, right? We don't have entry for 2D. So what it will do is initially it is going to flood. It's going to send out of all the ports. Now we call this as flooding, or it's one kind of broadcast where it is going to send a request to everyone saying that who is 2D, the MAC address. Now in this scenario, all the devices, they don't reply, they simply ignore the broadcast message. But whereas 1.4 is going to reply back, and when it is replying back, the source address will be, what the source address will be? The source address will be 2D, it will be reversed, and the destination address will be AA. Now here the entire process is done based on the MAC, because the switches do not understand the IP addresses. Now when it is replying back, the source address, it's coming from 1.4, it's coming back here on port number 4. So it will see on port number 4 there is no entry, so it will write down that if any packet come, so the next time if any packets come for 2D, it will send on port number 4. So it will write down and it will see what is the destination MAC is AA, and you have an entry for AA. It is on which port number? Port number 1. So it will directly forward the packet as a unicast directly on port number 1 instead of broadcasting. Now based on this information, the MAC table is updated. So let me write down, as of now you have an entry for AA and 2D, that is on port number 4. So next time, let's say there is one user from 1.2 want to communicate with 1.4, and the MAC address is AB instead of AA. Now the request comes from port number 2, and the switch will write down on port number 2 that there is a device with a MAC address of AD, and it will see the destination address 2D. It will check whether there is an entry is there or not. If there is an entry, then it will simply forward the packet directly on port number 4 as a unicast instead of broadcast. Now there are two important things we need to know in this with these examples. There are two things we are going to learn. The first thing, how the switches learns the MAC address. Now, generally we say switches do unicast and broadcast. Now we are going to learn how the switches are going to update the MAC table or learn the MAC addresses. Now the basic thing is switches will do broadcast initially for the first time. Switches will do broadcast or flooding if the destination MAC address is unknown. If it is unknown, because initially when you power on the switch for the first time, the MAC table will be empty, but based on the first broadcast message, it is going to update that MAC table, so that next time if any user is trying to communicate with the same MAC, then it can send as a unicast. So which means initially it is going to do broadcast, but later on it will do unicast. Later on it will do unicast if the destination MAC address is known. Known means it should be present in the MAC table. And the second point we need to understand here is it is going to update the MAC table based on the source address. When the first time the particular packet comes with that particular source, it is going to write down that entry in the MAC table, so that the next time if it has to send any information to this destination MAC from any source, it can send as a unicast packet rather than sending as a broadcast. So that's another thing you need to understand here. It always updates the source, the MAC table based on the source address, and these entries will remain in this MAC table. The default timer will be inactive time of 300 seconds. So which means if there is no traffic coming for this destination MAC for less than or more than 300 seconds, in that case it will remove these entries. So that is the default timer for these MAC entries. And these things you can verify with a command called show MAC address table. So let's verify these entries here. Now for verification we can go to switch, and there is a command called show MAC address table. Now you can see there are some entries. Let's generate some traffic. I'll go to my PC here. I'll generate some traffic for different devices, and you can see ARP entries also will be removed after some time. Right now it's still there, and then 1.2, and then 1.3, and then 1.4. So I'm generating a traffic from one of the computer to all the remaining devices, and if we verify show MAC address table, you can see these entries are updated. So next time if any user want to go to this MAC address, it will directly send on port number 2 as a unicast message instead of sending a broadcast. Now this is what we call as intelligence, which is something what we have in the switches. They are more intelligent devices because they can identify the device based on the MAC, and they can store that information on which port number what MAC address is connected. But initially they don't maintain that. That's the reason they do broadcast. But this mechanism is not present in the hubs. Now in the hubs they don't have any intelligence. They cannot identify dividers based on the MAC, and anything coming on one port, it will simply send out of all the ports all the time. They always do broadcast because they cannot send as a unicast because they cannot identify the device based on the MAC. They simply send the information in the form of signals, the zeros and the ones, binary digits, just in the form of zeros and the ones converted into equivalent signals. But switches, they do broadcast initially for the first time if they don't know the destination address, but later on they do unicast because they can identify the device based on the physical address or the MAC address. And the switches maintains a table called MAC table. Based on that, they can keep the information on which port what is the MAC address connected, so that they can forward it as a unicast.